Today we start our first unit in physics, and we call it kinematics. Kinematics is the study of motion. You did motion last year in physics or in Science 10. Right? You did motion, velocity, acceleration, time, distance, displacement. Well, we're going to do it again, but in more detail. That's kinematics, the study of motion. But kinematics specifically is a study of motion without regard to what causes the motion. So in other words, we're going to study the motion itself. We're not going to pay any attention to what it is exactly that caused the motion. Does anybody know, by the way, what it is that does cause motion? Good, force. Forces cause motion. So in other words, in this unit, we know that forces cause motion, but we're not going to pay attention to those forces. That's next unit that we're going to study the forces. We're just going to study the motion itself in this unit. Now, in order to do that, we have to be familiar with a couple of terms that you learned in Science 10, but we'll spend a couple minutes reviewing right now. First one's called a vector. A vector is a quantity or a measurement or a number with both magnitude and direction. What does magnitude mean? Yeah? Yeah, how big it is. Right? The amount. How much you have of something. I'm traveling at 30 kilometers per hour. That's how big it is that I'm moving, how fast I'm moving. My mass is 73 kilograms. That's how big I am, the amount of mass that I have. Versus direction, which is an arrow representing which way something is, right? A vector has both magnitude or an amount and a direction. Versus a scalar, which has just magnitude. So in other words, if I said I was driving at 100 kilometers per hour, well, that would be a scalar. If I said I was driving 100 kilometers per hour to the north, that would be a vector. They both have magnitude, but vectors have magnitude and direction. Now, you guys learned that in Science 10, right? But some of you probably forgot it. That's fine. Some of you might forget it between now and the end of Physics 20. I hope not. In an effort to try to keep you from forgetting the difference between a vector and a scalar, I'll tell you a little story about something that I observed a number of years ago, about 15 years ago. I was at a grocery store doing grocery shopping with my wife. I don't like grocery shopping. Sometimes what I do when I'm grocery shopping with my wife is I just kind of I read the labels or I watch people. I just do something to keep myself entertained. Well, this night I was in the cereal aisle, and I was walking up the cereal aisle, and I decided to just read backs of cereal packages. And I came to this vector cereal. You guys, anybody ever had vector cereal? They actually call it a meal replacement, right? Not vector cereal, it's vector meal replacement. You've had it? Is it good? I've never actually had it. It's okay? Yeah? I remember they used to market this a lot more than they do now, but they still have it. They still buy it. So I remember looking at the box thinking, I wonder if there's really any difference between this and any other cereal, like cornflakes, let's say. They market it as a meal replacement as opposed to cereal. But I wonder if there's really any difference between a meal replacement and a cereal. So I'm looking at the box, looking at all the nutritional stuff and stuff, and the ingredients and stuff. And you know what? Really, there's not that much difference. There is a little bit more in terms of vitamins and so on in vector cereal or meal replacement than there is in, say, cornflakes or Fruit Loops. But there's not much. Okay, it's mostly marketing. But that's not what struck me when I read the label. What struck me when I read the label for vector cereal or vector meal replacement is that vector was the only cereal in the aisle that had both magnitude, right? It says 400 grams. That's magnitude. That's how big the box is, the size of the box. But vector cereal is the only one in the cereal aisle that says on the side of the box, directions for use. Now, get this. Let me read it to you. Let me read you the directions in case you're having trouble eating cereal. It says, place 55 grams of vector in a bowl. And then it says, add 200 mils of milk. So just in case you didn't know how to eat cereal, you put the cereal in a bowl, and then you add milk. It doesn't say what to do next, so you're going to have to figure the rest out on your own. But it struck me, firstly, as, okay, who needs instructions as to how to eat cereal? Secondly, I thought it was kind of funny that vector cereal was the only cereal with magnitude, the size of the box, and direction. And now, it's not the kind of direction that we're talking about with a vector, right? A real vector is a direction like north, south, east, or west. This is a direction like how to do something. But it's still a way to remember the difference, right? If you're ever thinking, oh man, which one was it? Which one had directions? Vector cereal has direction for use on the side of it. So that's your way to remember which one is a vector, which one is a scalar. Scalars have magnitude. All boxes of cereal have the size of the box on it, right? But only vector has magnitude and direction. Got that? Hey, don't forget that. By the way, that was a number of years ago that I did that. I bought the box of cereal that night, and this is the box. Give you some idea. On the box, the back of the box, there's a goaltender that used to play for the Toronto Maple Leafs, Curtis Joseph. It's been a long time. You guys probably wouldn't even know who he is. It's been a long time since he played. The expiry date on this, well, I'll tell you what, this gives you some idea as to how long ago it was. When I bought this, I could read it like this. Now I have to hold it this far away from me. That's how long ago that was that I bought it. It expired on November 13th, 2003. So we won't try this, right? It's expired for 15 years almost, 14 years, but vector has both magnitude and direction. All right, here's a table that has 3 terms on it. Notice there's 3 blanks at the bottom. We're not going to do those right now. Those come later on, okay? Right now, it's only the first 3 terms that we want to look at. So if you want to make your table just 3 rows wide here, that's fine. The bottom 3 ones will just make a separate table later on. We got 3 terms: distance, position, and displacement. We want to define each of those terms. We want to tell what each of those terms mean. We want the symbol for each of these terms. In other words, how are we going to represent them? Like, what are we going to write down in short form so that we know what we're talking about instead of writing down the whole word? What are the units? In other words, like when I look at this box of cereal, it says 400 grams. The units are grams. How we measure it in. And then whether it's a vector or a scalar. Distance, we're going to define simply as how far something travels. How far something travels. That's pretty intuitive, right? If I stand right here near the front of the room and I walk 5 meters towards the back of the room, my distance traveled is 5 meters because I've traveled 5 meters. That's how far something's traveled, how far specifically I've traveled. The symbol for distance is usually delta D. D meaning distance, of course. What does that upside down triangle mean? Right here. That's my delta, but do you know what that means? Yeah, it's a Greek letter. Delta is a Greek letter, and it means change. So when I say delta D, I'm talking about distance, and I'm inferring a change. I changed from being here to 5 meters away from here. There was a change there, right? That's why we put that delta there, delta D. The units for distance are usually meters. although they don't have to be, at least not always. But that's the standard unit. That's, if in doubt, that's what we should use, meters. And distance is it's a scalar, yeah. When we're talking about distance, we don't care which way I went. We just care how far I went. Okay, right now, I'm at the start. I walked 5 meters. My distance traveled is 5 meters. Now, sometimes it may matter that I went backwards or forwards. That's not distance, though. If I care about which way I went, that's something different, not distance. Distance is just how far I went. You guys are going to do a field trip to Edmonton in a few months here. The distance that you will travel that day is about 700 kilometers in a bus. 700 kilometers. The distance doesn't tell us which way we're going. Are we going north or south or east or west? Whatever. My watch tells me at the end of the day how far I've gone. It doesn't tell me which way I went, what my direction was. It just tells me the distance that I walked. 10 kilometers, 13 kilometers, 7 kilometers, whatever the case may be. Distance is a scalar because the direction doesn't matter. Position. Position is the location of something. The location of something, where something is. Where am I? Well, I'm about 2 meters from the front of the room, 2 meters north of the wall. It's not enough to say I'm 2 meters from the wall, because I could be like anywhere 2 meters from the wall, right? I'm 2 meters. If I want to identify where I am or my location, then I need to identify that I'm 2 meters north of the wall. Okay, there's a school dance coming up here, I think, in a little while here, in a month or so. You're at that school dance, and you meet somebody. Oh, this is the person I've been dreaming about for my whole life. And they give you their phone number. Hey, that's great. And say like, hey, you want to go to a movie sometime? And person says, yeah, that'd be great. And then you say, well, where do you live? I'll pick you up. And they say, well, I live 17 kilometers from Dairy Queen. Well, that's not very helpful. Okay, if you want somebody's location or somebody's position, then you don't need it 70 kilometers from Dairy Queen. You need to know that it's 17 kilometers west of Dairy Queen or 17 kilometers north of Dairy Queen, right? If you want a position, you need direction. Therefore, position is a vector. The symbol for position, by the way, is a D. You ever seen this symbol with a little half arrow over top of it? Yeah, did you guys use that in Science 10? The half arrow reminds us that it's a vector. The units would be the same as distance, meters. At least that's the typical units. We could use sometimes other units as well, but the standard units, the normal units, are meters there. Displacement. Displacement is the change in position. The change in position. So position is where we are, or my location. The change in position is, well, what is my location changed by? If my position right now is 2 meters north of the wall, and my position right now is 5 meters north of the wall, then my change in position is 3 meters north. Does that make sense? My position has changed by 3 meters to the north. Is displacement a vector or a scalar? It's a vector, because position is a vector, so displacement, the change in position, has to be a vector. What do you think the symbol for displacement would be? Yeah?
Delta
Good. Look, it's change in position. Here's position. Here's change. So my displacement or my change in position would be delta D. And the units, of course, are going to be meters. Or at least those are the standard units. So I'm going to go for a little walk in the classroom here, and I'm going to ask you a few different things about my walk. Okay? Let's say, firstly, that I start off with an initial position. This is where I am, 2 meters north of the wall. Got it? Okay, so here's the wall. I start off 2 meters north of that wall. Okay, make sense? Okay, so here's my little walk. Okay, I'm going to walk forward. Okay, I'm going to walk north of the wall. I'm going to walk 1, 2, 3, 4, 5, 6 meters. What's my position now? I was 2 meters north of the wall. I just walked 6 meters. What's my position now? 8 meters north of the wall, right? Does that make sense? What's my distance traveled there? 6 meters. What's my displacement? 6 meters north. Good. You understand the difference there? My position was 2. Now my position is 8. My distance is 6, because that's how far I went. And my displacement is 6 to the north, because that's my change in position. It required a direction. Okay, let's try this one now. Start again. I start in the same place. Every example I have is going to start in the same place here, 2 meters north of the wall. Okay? Now I'm 2 meters north of the wall. Now I'm going to walk my 6 paces again. 1, 2, 3, 4, 5, 6. I'm going to turn around and walk 3 back. 1, 2, 3. What was my initial position? 2 meters north of the wall. What's my final position?
5 meters out of the wall.
I started 2 meters. I went 6 meters forward, 3 meters back. So I end up being 3 meters ahead of where I started. So my final position would be 5 meters north of the wall. Make sense? So I went here and then back to here. What was my distance traveled? What was my distance traveled? 9 meters, right? That's how far I went. If I was looking at the odometer in my car, or if I had a pedometer on, it would show 9 meters, right? It doesn't include direction. It doesn't matter which way I went, forward, backwards, it doesn't matter. I walked 9 meters. That would be my distance traveled. So this would be my initial position. We'll call that DI. We'll call this DF, my final position. My distance traveled, delta D, would be 9 meters. What would be my displacement? Displacement. Good. Displacement is 3 meters north, because the displacement is the change in position. 5 meters minus 2 meters is 3 meters to the north. Does that make some sense? When I walked 6, then 3, my distance was 9. But because I switched directions, my displacement ended up only being 3. I ended up 3 ahead of where I started. Make sense? Here's the thing. Distance and displacement will be the same number. Always. They'll always be the same number unless we switch directions. If I walk 1 meter and then I walk 2 meters in the same direction, my displacement is 3, my distance is 3. But if I walk 2 meters and then turn around and walk 1 meter, my distance is 3 and my displacement is 1. Does that make sense? So displacement requires direction. But if my direction doesn't change, it's the same as distance. If it does change, it's different than distance. Now, there's 2 ways that we can find displacement, distance and displacement. two mathematical ways. Other than counting up steps, there's two mathematical ways to find distance and displacement here. If you want to find displacement given positions, you will subtract them. So if this is where I am and this is where I was, we subtract those two numbers, we're going to get displacements. In other words, we subtract positions. Final minus initial. The other way to do it, depending upon what we're given here, is to add displacements. What do we mean by that exactly? This is where I am, this is where I was, then subtract them. If this is how far I went, and then this is how far I went, then we add them. So for example, my final position is 4 meters to the north. My initial was 1 meter to the north. That's where I am, right? 4 minus 1 is 3 meters. That's my displacement. But if I walked 1 meter and then I walked 4 meters, then my displacement would be 5. I subtracted them if they were positions. I added them if they were displacements. We'll do an example of that in just a second, a more formal example of that in just a second, and hopefully make that a little bit clearer. Let's take a look at example number 1 on the handout that I gave you earlier. It says a student is walking from 7-Eleven to the dog stadium at the bottom of the hill. You guys know what I mean, right? You go down 32nd Street here, you hit 7-Eleven, you keep going, you hit the baseball stadium at the bottom of the hill. The student is walking from the 7-Eleven to the baseball stadium. 7-Eleven is 1 kilometer south of HTA, and the dog stadium is blank kilometers south of HTA. Does it say on there? It just says blank on there as well. It's 2.5 kilometers, by the way. So that should say 2.5 kilometers south of HTA. What's the displacement of the student as she walks from 7-Eleven to the dog stadium? Let's draw this out. Here's HTA. Here's 7-Eleven, which is 1 kilometer south of HTA. And then here's the dog stadium, the baseball stadium down here. Which is 2.5 kilometers south of HTA. What's the displacement as this student walked from 7-Eleven to the dog stadium? Remember, there's two ways I can find this. Depends on what I have. If I have positions, then I'm going to subtract. If I have displacements, then I'm going to add. What do I have here? Did this student walk 1 kilometer, or did this student start at that position 1 kilometer? Started at that position, right? So that 1 kilometer is my initial position, and 2.5 kilometers is my final position. That's where I am, and that's where I was. It's not how far I traveled. So I'm going to subtract. Subtract positions. My displacement will be 2.5 kilometers, my final position, minus 1.0 kilometers. That's my initial position. So what's my displacement? It's going to be 1.5 kilometers, right? Right? Does that make sense? If I go from 7-Eleven to the dog stadium, I haven't walked 4 kilometers. We're not going to add those numbers together. We're going to subtract them because they were positions. Now, I'm going to show you something here that may confuse you a little bit, but hopefully not. Usually when we say north or east, we make the numbers positive. When we say south or west, we usually make the numbers negative. So usually here, we would make this negative 2.5 and negative 1 because they're south. If we did that, this would end up giving us negative 1.5 kilometers, which makes sense, right? Because our displacement is 1.5 kilometers to the south. Does that make sense? In the end, in this question, it doesn't really matter how you do it, make it positive or negative. But when you've got a north and a south in the same problem, then it becomes really useful to make one of them positive and one of them negative. Using north positive, south negative. I'm going to write down here that south is negative just to kind of refresh my memory on that. By the way, what would my distance traveled be? My displacement is 1.5 to the south, or negative 1.5. What's my distance traveled? I'll give you a hint. It's easy. Like really easy at this point. 1.5. Why is it the same as displacement minus the direction? Because I didn't change direction. Good. If I had to turn around at some point, then distance and displacement would be different, right? If I run around the track outside, how long is the track? You guys know how long the track is? 400 meters. If I run around the track, what's my distance traveled around the track? 400 meters. Right? What's my displacement? 0. Why are the two numbers different? Because when I ran around the track, I changed direction. Let's do one more example here. Student walks 1.5 kilometers south from the 7-Eleven to the dog stadium, then turns around and walks 2.5 kilometers north to HTA. What's the distance traveled by the student? What's the displacement of the student? Let's worry about displacement first. We're going to add these two numbers or subtract them? Are these numbers that are given to me, do these numbers represent where I am or how far I've gone? My position is not 1.5 kilometers or 2.5. This is where I am. This is how far I travel. I move 1.5, and then I move 2.5. I'm going to add those together, right? We subtract positions or we add displacements. Now, what do I want to be careful of here that I've missed? What do I want to add in red? Yeah, 1.5 is to the south, 2.5 is to the north, so we'll make the 1.5 negative. We'll say north is positive, therefore south is negative. Let's add these together. We end up getting 1.0 kilometer. So my displacement is 1.0 kilometer. Hey, by the way, I got a positive number for that. What does that mean? Yep. Yeah. If I had gotten negative 1, it would have been 1 to the south. But I got positive, so it's to the north. There's my displacement. What about my distance traveled now? For this one, I just said 1.5 plus 2.5 is 4. Why did I not put the negative in for the 1.5? Because distance is a scalar. Displacement's a vector. When there's a direction, I need to include it. Distance is a scalar, so I drop the direction. I don't care about the negative there. Anybody tell me why displacement is a different number than distance? Lots of times they're the same number, right? Distance and displacement are two different numbers here because what? The direction matters, yes. I changed direction. All right, in the last question, I kept going in the same direction. This one, I changed direction. All right? All right, guys, so I'm asking everybody right now to take a look at question number 1 on your worksheet. Just question number 1. After you're done that, just stop. We'll take a look at it, And then we'll have you do question number 2 and so on for the first few questions until we're sure that you're getting on to the right track with this. And then we'll set you free to work on the rest of the questions. So number 1, if you're having any trouble with it, ask me a question. If you're not, good, get it done, and then we'll go over it as a class in just a minute. All right, guys, number 1 says a woman runs 100 to the north and walks 200 meters to the north and then runs 100 meters to the north again. What's her distance traveled? What's her displacement? Are these numbers that are given to me positions, or are they displacements? In other words, do these represent where this woman is, or where she's gone? How far she's traveled, her displacement. These are displacements, right? So what are we going to do? We're going to add them or subtract them? We're going to add them. Now, for distance, all we're going to do is add the distances together. 100 meters plus 200 meters plus 100 meters gives me a total of 400 meters. For displacement, we would pay attention to signs, but since they're all north, it's going to be positive as well, right? We're going to say positive 100 meters plus positive 200 meters plus positive 100 meters gives me positive 400 meters. And what does the positive mean there? North, right? This one, like this one's not north, that's just distance. This one's north because it's displacement and it requires a direction. Can you tell me why those two numbers are the same? We didn't change direction, right? It was north the whole time. Okay, take a look at number 2. Time for number 2 says a man walks 20 meters to the north, then 50 meters to the south, and then 100 meters to the north. What's the man's distance traveled? Well, what do we have given to us here? Are these displacements or are these positions? These are displacements. This doesn't tell us where the man is. This tells us how far the man has gone. So we're going to say to find the distance traveled, all we're going to do is add them together. We're not going to pay any attention to the north or south here because distance is a scalar. 20 meters to the north plus 50 meters to the south plus 100 meters to the north gives me a total distance traveled of 170 meters. Does that make sense? 170 meters there? For distance, right? For distance traveled. What about displacement? Well, we're still going to add them together, but this time we have to add including signs, including direction. Let's make north positive, just like we did in the last question. That means that we walk positive 20 meters plus what? Negative 50, good. Negative 50 meters plus positive 100. So that gives me a total distance traveled of, what is that going to be? 70, I think it is? 70 meters? It's going to be positive 70 meters. The positive means to the north, right? Now, why are those two numbers different? Because we changed direction. Question number 1, we didn't change direction, right? It was north the whole time. Here we have north and south, so we changed direction. All right, what I'd like you to do here, guys, is take a look at now 2 of them, questions 3 and 4. And once you've done 3 and 4, then depending upon where we're at here in class, we'll take a look at those questions, okay? 3 and 4 now before we look at anything. Question 3 says a man runs 400 meters around the track and then another 400 meters around the track again. Boy's back to where he started at the end here. What's his distance traveled? 800 meters. His distance traveled, remember, delta D with no arrow over it, that's distance, is equal to 400 meters plus 400 meters equals 800 meters. What's his displacement? 0, because he's back where he started.